Okay, so we were talking about our cylinder, area of the base times height. Well, hopefully you realize that the area of the base of a cylinder, or sorry, the shape of the base of a cylinder is a circle, right? Circle here and circle here. So for a cylinder, the area of the base is pi r squared. And the way this always works with this area of the base times the height is imagine that you had this and you could just shave off the tiniest little, the thinnest circle at the bottom. So it had no height, but it was just a very thin circle that had that area, pi r squared. And then we could keep shaving and shaving and shaving. Well, if I stacked up those like infinitely small little shavings, I'd have enough of them to make up this height, right? So each of them, one of them would only have an area, not any height, but then together that would make my height of my can. Now, what if I have, and so this is for a cylinder, right? What if instead of a cylinder, I have a cone? Well, I still have that circle on the bottom, okay? But obviously, if I were thinking of this as compared to a cylinder, I'm missing part over here and part over here. So anytime you have something that goes up to a point instead of staying straight, like a pyramid goes up to a point, your volume formula is going to be 1/3 area of the base times height. So for a cone, it would be 1/3 pi r squared h. Okay? Oops, 1/3. Because if you think about it, if you think about this space up here being in 3 parts, there's 1, there's 2, there's 3. I only have one of those 3 parts. And then the last thing we talked about was if we could think about the surface area of this cylinder. Okay, so surface area is where we take the area of all the different faces or sides and add them up. So for a cylinder, here's the surface area formula. Okay, 2 pi r squared plus 2 pi r h. So let's just think for a minute about why that is the surface area. So in our class, I think I had them, the people who were there, go out into a breakout room to like a little group and think it over, come back. So I would love it if you would pause the video and think about it for a minute and see if you can come up with why that is. But then if you get stumped, we will go over it together here. So the first thing I would ask you to do is to think about the day that we made shapes out of paper. Okay, we had those on paper and then I cut them out, or you cut them out and taped them together and you made a cylinder. So if you can think back to that day, do you remember what the cylinder net looked like? Remember, the net is like the pattern. Well, if you think of that, it looked like this. Okay, so you take this rectangle, okay, and this rectangle, it's like having a piece of paper here. Here's my rectangle. And if you roll up that rectangle, then essentially, you tape it, right? I have my cylinder. Can't quite hold it perfectly, but you can see it's my cylinder. What is it missing? Well, it's missing the top and the bottom. So on that net, if I had a circle over here and a circle down here, then when I roll it up, my circles are still attached, right? It can just flop over and make the top, flop over and make the bottom. So that's how that net gave me a cylinder. So let's look at this part first. Okay. And this goes along with the top and the bottom. So if I think about the top and the bottom, let's just think about one of them. Let's think about the bottom first. So the surface area is the sum of all the different areas of the surfaces on all the sides. So here's the bottom. It's a circle. So the area of this circle is pi r squared. Okay. Well, what's the area of this one going to be? This is also a circle. It's going to have the same radius because it's got to fill up the same size hole. The top and the bottom of the cylinder are the same. So this area is pi r squared. So when I'm doing my surface area, I have the top plus the bottom plus the side, right? that side is really all one piece. There aren't separate sides in a cylinder. It's all one piece. So the area of the top is going to be pi r squared. The area of the bottom is also going to be pi r squared. Pi r squared plus another pi r squared is going to be two of them, just like x plus x would be 2x, right? So this is where this comes from. This is the top and the bottom. So now let's think about this side part. Okay, so this side, when it unrolls, or if we were to take our can and cut it, that round part is really just a rectangle that was, connected together. So what's the area of a rectangle? Well, the area of a rectangle is base times height, little b this time, right? The big B in the volume formula means area of the base. This is just little b. Base times height. Which is great. We can put base times height over here. But that would introduce another variable. And if I look at my can again, and I say, okay, so this part, the area of this part is going to be base times the height. Here's the height. How do I find a base? I don't even really see a rectangle when it's like that. We have to think back to how it comes apart, basically. So here's my unfolded sides, okay? So I can see it's a rectangle. Base times height. Height is easy. It's this base that we need to worry about. What's the length of this base? Well, the trick is to think about it, not only like its rectangle, but think about it in its cylinder form. So it's a little hard to hold it like this, but when we think about it in its cylinder form, okay, which obviously would not be overlapping like mine is here, but it's a little easier to hold that way. Okay, so this is the height, and this is my base now. I circled it. I made a circle out of it. Well, the base, that base goes all the way around from here all the way around to here, right? That's what I took my rectangle and I just put it together. What do we call this around the edge of a circle? Well, we call it circumference. So my rectangle, the base of my rectangle, this part right here, is the same length as around my circle, right? I didn't change anything. I just opened it up, closed it. So if I know the circumference of the circle, of the cylinder, or of the circle on the base, which is 2 pi r, that's the same as this length of a base. And then I have it times my height. Okay, it probably will make a little more sense to you if you actually take a piece of paper, just any piece of paper, kind of put it together. Okay, you can see that what was your base of your rectangle is now the same as the circumference of that circle. Okay, so that's where that surface area formula came from. So that was what we did with spheres and talking about pi. Again, it's kind of cool that you think about that no matter what circle you're talking about, if you take the circumference and you divide it by the diameter, then you will get pi every single time. And I had mentioned the other day these circumference series of books by Cindy Neuschwander, and there is one called Circumference, and the Dragon of Pi, and they talk. That's what the whole story is about. It's a little story. They're trying to find stuff, and like one of the situations is they're measuring all different things and realizing that there's this relationship between the diameter and the circumference. So someday in your classroom, that's a really good book. It really hits home in a way I think I hadn't even thought about it until I was using those. All right, so if you didn't get a chance to do the homework from last week because I hadn't put the video up, that's fine. Just try to get it in this week sometime. And then I will be having some new stuff up. We do not have class on Wednesday the 15th because of registration day. So we won't have a Zoom class, so we'll have a little less new material this week. All right, I will talk to you guys soon. Bye-bye.